Guys, welcome back to our video series of software engineering. We are going to continue with techniques for estimating software development cost. It can be very tricky, to estimate the cost of a software. Imagine a scenario where you say that you need like 30 million to develop a software, and later on you realize that in fact you need the double of that. You need 60 million or 50 million, or even if it's 35. That's a problem. So it's very critical to estimate the cost. So here we are talking of techniques, that can be very helpful, when it comes to estimate the cost, of a project. So we are going to talk about 6 techniques. We are going to talk about analogous estimating, parametric estimating, bottom-up estimating, 3-point estimating. We are going to talk about the cost of quality, and then vendor bid analysis. So these are the techniques that we are going to cover here. So what is analogous estimating? Analogous estimating simply means that when you have to estimate the cost of a new project, you base your estimation on a previous similar project. Let's say if you have built let's say if you have built a human resource system, you have built a human resource system for one client, and it costs like 50 million. Let's say it costs 50 million, and you have a similar organization, requesting you to build a system for them. An organization of the same size, let's take for example RDB and Rwanda Revenue. So these are organizations of almost the same size. You see, now what you do is, if you have built it for RDB, if you have built it for RDB, let's say for 50 million, now you know that for Rwanda Revenue is going to cost around that. Though Rwanda Revenue might be, a bit bigger, it's huge, it has sites everywhere. So you then, if it was 50 million for RDB, you know that it's turning around 60-70 million for Rwanda Revenue. So you base your estimation, on previous project. So we don't mean that you estimate, you give the same amount, but you judge the size of the company or the organization, you judge the duration, and so on, and even the size of the assignment. Now you compare with previous similar project, and then you base your estimation on that. Yeah, so that is analogous estimation. Now what about parametric estimation? With parametric estimation, now you you multiply, you have quantities of you have different quantities, and then you or numbers, and then you multiply it by 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 items, or number of items, and that gives you an estimation of the cost. So parametric estimation involves calculation. So we are going to see an example. So let me give you an example. So this is a project. Let's say design of HR system. Just an example. Now we have here also is HR system. Here we have HR system. HR system, and then HR system. HR system. So now, what do we have here? So you see that we have quantities. When you have units, when you have item like this and unit, and you have quantities, and then unit prices. So this is parametric. Parametric. So it involves calculation. Like here, for example, you see you have the breakdown of remuneration. So you define that for this consultant, who is going to work for this how many number of days, this is a daily rate or remuneration, and this is the amount. You see, so this is parametric. So when you have items, unit prices, quantities, numbers, and you have multiplication of all these parameters, so we are talking about parametric estimation. So this you can't do without parametric estimation, so it is always there. You break down your cost, and then you multiply by with numbers, number of days, number of consultant, unit prices, daily rates or any other rates, then you come up with an amount that you sum, to have subtotals and totals. So this is parametric estimating. For example, here you can even estimate. Parametric estimating uses statistical relationship between relevant historical data and other variables like the number source of code, to calculate a cost estimate for a project work. So you can even one parameter can even be the number of source of code. You can estimate the number of source of code, and then you calculate, and you say that for like 1,000 line of code, this is the cost. How many line of code you are going to have, and then you make multiplication. So just remember that when it involves the multiplication of different variables or parameters like unit prices, numbers, daily rates, or any rates, so that this is parametric estimation, and all project use parametric estimation. Now this bottom up estimation, just like you understand, you estimate, you break down your project, and then you estimate different work packages, and then you sum up, you know you sum up the cost. Let's take an example here. This is an example. So we have our project here, and we have different phases. We have different work breakdown. We have different work breakdown. So we have project management. Which has these sub-habit item: planning, controlling, reporting. We have requirement management, with this breakdown. We have development and integration with this breakdown. We have testing and go live with this breakdown. So here you see that we have broken our project into sub let's say kind of sub project. These are called work breakdown. So we break down the work. So instead of having the whole project, estimating the whole project, what you do is you break it into sub project, or component, and then you estimate the cost of each component, and then you sum them up. So for example, here we have project management, requirement management, development and integration, testing and go live. Now what do we do here? So here is the cost of project management. So here is the cost of requirement management. Here is the cost of development and integration, and here is the cost of test and go and going live. So these are, now what you do now, you sum them up. You see here, you know that project management is 187. This one 187, this part here, 187,000 USD, this part. And then this one is 104,000. This one requirement 104,000 USD. Here 408 development and integration, 408,000. This part 408,000 USD. And then testing and go live goes for 194 something. So now this is one bottom, another bottom, another bottom, another bottom, and then you sum them up. You sum them up to have the overall project cost. The overall project cost is 893. And you see that all these uses parametric estimation. So you use parametric estimation in conjunction with bottom-up estimation. Why is it parametric? Because you have, the number of resources here. You have duration in terms of days. Then you have unit prices, and then you multiply. You have a rate here, and then you multiply this times this gives you this, this times this gives you this times this gives you this, and so on. So you multiply this times this, give you this, and so on. So this is parametric. So it's parametric because you have some calculation here involving different parameters or variables. You multiply them, and then it is bottom up because you evaluate separately each work breakdown, and then you sum them up later. So this is bottom up. So even here you see, for example, here you have the breakdown of remuneration. This is one work breakdown, and then you have here you have breakdown of cost by activity, and then here you have breakdown of reimbursable expenses. There here all these uses parametric estimation, and then here you have the cost summary. So you summarize remuneration and then reimbursable fees, and this gives you the project. So parametric estimation and then bottom up estimation are the two key techniques used in software cost estimation. So in the next video we are going to cover other techniques. We are going to start with T-point estimating. T-point estimating, which uses beta distribution. So we have covered beta distribution when we were talking about PERT, but does not only uses beta distribution, it can also use triangular estimation. So we are going to cover that in the next video. So I hope you guys have enjoyed this video about analogous estimating, parametric estimating, and then bottom up estimating. So thank you for watching. So I see you in the next video. Bye bye.